Hey guys, so we're going to go ahead and kick off 8.2.2. Hopefully this video will go okay and you won't get a ton of feedback, but if so, just be patient. I will figure it out in the weeks to come, how to make these a little cleaner hopefully. So what we're going to talk about today is how the area changes as the size of a figure changes. So this is kind of picking up from where we left off last week. And we're going to be investigating ratios between similar figures, both with area and perimeter. So we're going to kind of go past just the area we were looking at and now also include perimeter. So we're going to go ahead and do question 78 fully together as a whole group. There are going to be some points in the video where I ask you to pause and try a problem and then come back later. Please do that, as engaged as you can be in this. It's just going to make it better, and you're going to learn more if you are actually trying the problems and then going back and checking your answers. Okay, so when I say pause, please do pause and then do the problem. So let's go ahead and look at question 78. It says, Alice has a 4-inch by 5-inch photo of your school's championship girls ice hockey team. To celebrate their recent victory, your principal wants Alice to enlarge her photo for a display case near the main office. So I'm going to go ahead and kind of pick out the important parts of this question, which I think that 4-inch by 5-inch is probably pretty important. So now I'm going to go ahead and read part A. When Alice went to the print shop, she was confronted with many choices of sizes: 7 by 9, 8 by 10, and 12 by 16. She's afraid that if she picks the wrong size, part of the photo will be cut off. Which size should she pick and why? So I want you to go ahead and think about how should the sizes relate. So how can I determine which size would be the most appropriate for this situation? So go ahead and think about that for a second. Okay, so hopefully you've thought about that and you have realized that if she wants to pick the most appropriate size, she needs to figure out which one has proportional sides. Because if it doesn't have proportional side lengths with her original photo, then that means part of the photo is going to get cropped out. It's not going to include the whole thing. So we want to make sure we've got proportional side lengths. So let's look at the first one. It's a 7 by 9. So if I put 7 over 4, and then I put 9 over 5, the other length, do those equal each other? Well, we can see pretty easily, or you could try it with a calculator if you're not seeing it from here, that those are not going to be equal. They don't have any common factors. I can't simplify them to where they equal the same thing. So that means that 7 by 9 choice is probably not the best option. So now I'm going to go to the second one. It says 8 by 10. So I'm going to do 8, smaller number, right, divided by 4, smaller number. And want to see if that's proportional to 10 divided by 5. So does that equal? Well, we can see that that does. So the left side, 8 over 4, that simplifies to 2. The right side, 10 over 5, that simplifies to 2 as well. So in this one, the side lengths are proportional. So the 8 by 10 choice probably isn't a bad option, but let's just go ahead and check the last one just to be sure. So for the last choice, I have a 12 by 16. So I'm going to do 12, smaller number, over 4. And then 16, bigger number, over 5. And I can see that 12 over 4, that simplifies to 3, but 16 over 5 does not. So since those don't simplify to the same thing, then that means this is probably not a good option for us either. These are not proportional, so I'm not going to choose that 12 by 16 option. So what size should Alice pick and why? Well, she should pick that 8 by 10 option because it has proportional sides with the original 4 by 5 photo. So that's part A. All right, let's look into part B. It says, the cost of the photo paper to print Alice's 4 by 5-inch picture is 45 cents. Assuming that the cost per square inch, that's super important, of photo paper remains the same, or consistent, how much should it cost to print the enlarged photo? So we want to figure out how much it needs to cost to print the enlarged picture. Okay, and then explain how you find your answer. So I just want you to pause the video and think about that for a second. So hopefully you've thought about the fact that the new photo, the 8x10, is the side lengths are 2 times as big as the original photo. So I know that these two photos would have a zoom factor of 2. Remember, a zoom factor or a scale factor just compares the side lengths of similar figures. So I can see that that's 2. 8 divided by 4, 10 divided by 5. But we want to compare cost per square inch. So we want to compare the areas. That's what we'll use to calculate cost. So if you recall from the last unit, the area doesn't grow the same way the zoom factor grows. The area, the ratio of the areas, is the zoom factor squared. So that means the ratio of the two areas would be 2 squared, which is 4. So the cost should increase by 4 times, not 2 times. So if I wanted to calculate the cost of the enlarged photo, it should be 4 times the cost of the original photo, 45 cents. And if we calculate that out, that should be $1.80. Okay. And then finally we have part C. It says, unbeknownst to her, the vice principal also went out and ordered an enlargement of Alice's photo. However, the photo paper for his enlarged cost $7.20. What are the dimensions of the photo? All right, so we know that this principal or vice principal got a photo that was $7.20. We know that the original photo only cost 45 cents, and we know that from part B. So if we divide 720 by 45 cents, we get the ratio of the two areas, because remember the cost is calculated by areas, and that would be 16. Okay, so we know the area of the enlarged figure is 16 times bigger than the area of the original. Okay, so that means the zoom factor, we need that because we want to actually figure out what the dimensions are. So we don't need how much bigger the area is, we need how much bigger the side lengths are. So to get the zoom factor, what could I do to the ratio of the areas? That's what we want to think about. So go ahead and think about that for a second. What do I do to the ratio of the areas to get that zoom factor? All right, so remember we're moving from square inch to inches. So how do I get rid of the square in front of the inches? Well, I take the square root. So if I know that the ratio of the areas is 16, then I can take the square root of 16 to get the zoom factor. So then I know that the zoom factor is 4, which means the side lengths of the enlarged figure are 4 times as big as the side lengths of the original. So the side lengths of the new are 4 times bigger than the side lengths of the original. So if the original was a 4 by 5, then I need to multiply both of those side lengths by 4 to get the dimensions of the new one. Okay, so I can get that the dimensions of the new figure would be 16 by 20. That was a weird 0. Alrighty. So that's question 7-8, just kind of refreshing your memories to remember that, hey, the ratio of the areas is just the zoom factor squared. So if you have the ratio of the areas, you can square root it to get the zoom factor, and then also considering cost in that as well. All right, so on this next problem, we're going to do part B together, and then once we've done part B, you are going to pause the video and try part A and part C completely on your own, and then when you unpause the video, we will briefly talk about those, and I'll have the solutions for you on that. So question 79 says, so far you have discovered and used the relationship between areas of similar figures. How are the perimeters of similar figures related? Confirm your intuition by analyzing the pairs of similar shapes below. For each pair, calculate the areas and perimeters and complete the table like the one shown below. To help see patterns, reduce fractions to lowest terms, or find the corresponding decimal values. Okay, so we're going to go ahead and, like I said, and do part B. In part B, if I'm going to be finding the area and the perimeter, then I'm going to need to know the other side length. So this is a 30, 60, 90 triangle. I can calculate that top angle is 30 by subtracting 60 from 90. And then I can use that information to find the two sides that I don't know. So we know that we multiply the short leg by 2 to get the hypotenuse, so that would be 12 root 3. We know we multiply the short leg by root 3 to get the long leg, so that would be 6 root 3. So there are the two side lengths of my first triangle. Now I can go to the second triangle. So here I know that the hypotenuse is 4, so we divide by 2 to get the short leg. So I know the short leg there would be 2. If I know the short leg, then I can multiply it by root 3 to get the longer leg. So the longer leg must be 2 root 3. So now I've got both the side lengths in both. So first thing it asks us to do is to compare the ratio of the sides. So I'll compare the short leg in each one. So the short leg in the smaller figure is 2. The short leg in the larger figure is 6. So I know that the ratio of the sides would be 2 to 6, which is 1/3. The next thing it wants me to do is to find the perimeter of each triangle. So now I'm going to calculate that out. The perimeter of the smaller figure would be 2 plus 4 plus 2 root 3. So because of that root 3, I'm just going to calculate this out in my calculator, and I got for that perimeter that it was 9.464. Now I'm going to go and calculate the perimeter of the larger figure. So for perimeter of the larger figure, I'm going to do 6 plus 12 plus 6 root 3. And when I calculate that out, I get that that perimeter is approximately 28.392. Okay, so now I've got the perimeter of the smaller one and the perimeter of the larger one. And then the next thing it asks is for the ratio of the perimeters. So to find the ratio, I could divide those two perimeters. And if I do that, you should get that as approximately 1/3 as well. And if we would have left it in exact form in terms of radicals, left that 2 root 3 and that 6 root 3 there, we would have gotten exactly 1/3. So we can see here that the ratio of the perimeters is the same as the ratio of the sides. Okay, think about why that would be true. Okay, so just kind of ponder that for a minute. And then the next thing it asks us to do is to find the area of each triangle. So I'm going to start with the smaller triangle again. We know that we find the area of a triangle by computing base times height over 2. The base length of the triangle would be 2. The height would be the other leg, 2 root 3. Because remember, in a right triangle, you always use the two legs to calculate the area. So that becomes 2 root 3. And if you wanted, you could get that to a decimal. Just be sure to round it to at least 3 decimal places. So now we're going to do the area of the larger triangle, not perimeter. And its base length is 6. Its height is 6 root 3 over 2. So if I calculate that out, I get 36 divided by 2, which is 18. So the area of that larger triangle is 18 root 3. So I'm going to go ahead and record those in my chart as well. And then finally, it asks to compare the ratio of those areas. If I put 2 root 3 over 18 root 3, the root 3's cancel, so I get 2 over 18. I can take a 2 out of each of those, so I get 1 over 9. So the ratio of the areas would be 1 over 9. The ratio of the perimeters was 1 over 3. And the ratio of the sides was 1 over 3. So we can see clearly that the ratio of the areas is simply the scale factor squared. So what I want you to do now is pause the video. I'd like you to do part A and part C. And when you get back, the solutions to part A and C will be up. Okay, so here are the solutions to those two. So you can kind of take a look at these and figure out if you got them wrong or right. If I move along too fast, pause the video, check your work. So there were a few things you had to do on part A and C. You had to find the missing side length in part A, so you had to figure out that that side length was 10, and you could have done that by setting up a proportion. In part C, you had to figure out all the side lengths of the larger figure, so you had to realize that the side lengths were being multiplied by 8. So if you multiply both the other side lengths by 8, you get 104 and 40. And then to find the area, you had to figure out the height, and that was kind of interesting. So I think the easiest way to do that, you could have divided that middle thing into a rectangle, okay? And so once you divided that into a rectangle, then you could split it up into right triangles and then use a Pythagorean triple to figure out that that height would have to be 3 so that you could then find the area. Okay, so 2 final questions. I am going to allow you to kind of do these on your own as well. I'll read through them with you and go over them once you've had a chance to try them. So 80 says, while Jessie examines the 2 figures at the right, she wonders if they're similar. Decide with yourself if there is enough information to determine if the shapes are similar, and then justify your conclusion. So I want you to pause the video and think about that for a second. Okay, so this question was a little bit tricky. So if you divide 360 by 40, you get 9. If you divide 21 by 7, you get 3. So that may make you or lead you to believe that these are going to be similar because the ratio of the areas is 3 squared. However, we don't know anything else about this shape. We don't know that any of the angles are congruent. We don't know what's going on with these other remaining sides. And so because we don't know that all the sides keep that same proportion and we weren't told initially that those were similar, then we can't say whether or not for sure they are by just knowing one side length in each and the area of each. So that's just not quite enough information. If we knew more, maybe we could say they were. We just don't know. All right, so now let's look at question 81. This is the last question for today. It says, your teacher enlarged the figure at the right so that the area of the similar shape is 900 square centimeters. What is the perimeter of the enlarged figure? Be prepared to explain your method to the class, aka yourself. So go ahead, pause the video, try that one. Okay, so here's the solutions to this problem. So first thing I tried to do is determine what the ratio of the areas was by comparing. So I did 900 over 100 and got that the ratio of the areas was 9. So then I had to think about how the ratio of the perimeter related to the ratio of the area. Perimeter uses units like inches, feet, centimeters. Area uses feet squared, inches squared, centimeters squared. So if I know stuff about a squared unit, then I can square root that to get information about a unit that's not squared. So the ratio of the perimeters would just be the square root of the ratio of the areas, or 3. So I know that the perimeter of the larger figure is 3 times that of the smaller figure. So I found out that the perimeter of my smaller figure was 44 centimeters. And so if I wanted the perimeter of my larger figure, I can do 3 times 44, and I get that the perimeter of the larger figure must be 132 centimeters. Okay, that's pretty cool because we didn't have to draw the larger figure. We didn't have to find the actual side lengths of the larger figure. We are just using our knowledge of ratios to determine what those are. So that's all I've got for you today. Make sure you do the posted assignment on Google Classroom as a part of your homework, and I will talk to you guys later. Bye.